Lesson 11.2 Areas of trapezoids, rhombuses, and kites. Area of a trapezoid is 1/2 the height times base 1 plus base 2. So what we're doing, this 1/2 base 1 plus base 2 gives us the average length of the base, which would be the length of that segment there. Well, if I take this little triangle and flip it up there, and I take this little triangle and flip it up there, I end up with a rectangle whose width is 1/2 base 1 plus base 2, and whose height is h. Area of a rhombus is 1/2 d1 times d2. If I were to take this triangle and put it up there, and this triangle and put it up there, we have a rectangle whose base is d2 and his height is 1/2 of d1. So it's 1/2 d1 times d2. d1 and d2 are the diagonals. Likewise, area of a kite, same thing as a rhombus. Area is 1/2 d1 times d2, where they're the diagonals. So let's find the area. Well, what kind of shape is this? That's right, it's a trapezoid. What was the area of a trapezoid formula? 1/2 h times b1 plus b2. So let's look at these. Let's see, the height, well, these are the bases. Now it doesn't matter which one you call b1 and which one you call b2, because 8 plus 6 is the same as 6 plus 8. And the height here is 4. What's true about the base and the height? That's right, they're perpendicular. So I'm going to fill in the 6 and the 8 for the bases, the 4 for the height, and it comes out to be 1/2 4 is 2, 6 plus 8 is 14, so 2 times 14 is 28. What shape is this? That's right, it's a kite. The area of a kite is 1/2 d1 times d2. Well, this is a diagonal. We can call that one d1. And notice the 14 goes end to end. So that would be the same as if it went through the middle. So that is the length of the other diagonal. It's 1/2 6 times 14, just 42. How about the area of this shape? What shape is that? That's right, it's a rhombus. And the area of a rhombus is 1/2 d1 times d2. All right, now this 30 only goes halfway, so the whole diagonal would be 60. And this 40 is only halfway. The whole diagonal would be 80. So our diagonals are 60 and 80. Plug those in. 1/2 80 times 60 is 2,400. But wait, there's more. If the area of a kite is 80 square feet, one of the diagonals is 4 times as long as the other. Find the diagonal lengths. Well, let's see, we have area of a kite. Oh, wait, we have a formula for the area of a kite. Area is 1/2 d1 times d2. The other thing, it says a diagonal is, that's like equals, 4 times as long as the other. So we have one diagonal equals 4 times the other diagonal. So where the d1 is, I have put 4d2, because d1 equals 4d2. 1/2 of 4 is 2, and d2 times d2 is d2 squared. Divide by 2. 40 equals d2 squared. All right, so since it's squared, I need to square root. So d2 would be the square root of 40. Oh, we can simplify that. What times what makes 40? I want one of them to be a perfect square. So how about 4 times 10? So the square root of 4 is 2 times the square root of 10. But that's only half my answer. I need to know d1 also. If we look back over here, d1 is 4 times d2. So I need to multiply d2 by 4. 4 times 2 is 8. So d1 is 8 times the square root of 10. Last problem. Find the area of a rhombus with vertices 1, 3, 5, 5, 9, 3, 5, 1. If you look at my graph only goes to 6, but I need to graph points up through 9. So I'm going to have to count by 2's. So maybe we should start by plotting the points. And then since it's a rhombus, we can connect them all. And the area requires the lengths of the diagonals. So the diagonals are 8, that's from M to P. You can just count it if you want, or 9 minus 1 is 8. And the other diagonal is 4. That would be N to Q. You can just count it on the graph, or you can say, oh, 5 minus 1 is 4. Area is 1/2 d1 times d2. So I can fill in the 8 and the 4 for the diagonals. 1/2 8 times 4 is 16.